This first screencast about glaciation is looking at how has climate change affected the global distribution of ice, and we're looking at over recent geological past the fluctuations of temperature that have occurred and the changes that that's then had on the extent and distribution of ice in the world. Now, we are all aware of global warming and the possible impacts that might have on our weather and on the sea levels. However, concern about climate change is nothing new. As recently as the 1970s, some scientists suggested that the climate was actually cooling and there was talk of another ice age. Although the current warming trend may be linked to human activities, climate change in the past has been entirely natural. The most likely causes are to do with subtle variations in the Earth's orbit, so slight changes in its tilt towards the Sun, or variations in the global pattern of ocean currents which move heat around the world. Currently, slight changes in the ocean currents off the west coast of South America result in what's known as the El Niño effect. Now, this is a periodic blip in the usual global climate caused by a short-term warming of the cold ocean current that normally exists off the west coast of South America. It results in unusual patterns of temperature and rainfall and can lead to droughts and floods in certain parts of the world. Now, geological time is divided into periods, and the last ice age began around 2 million years ago during the Pleistocene era. During this ice age, there were cooler times, as you can see here, marked by these blue areas, which are known as glacial periods, when the ice actually advanced and travelled further across the world. And there are warmer times, as you can see by the red periods, which were known as interglacial periods, when the ice actually retreated. Evidence from ice cores and deep-sea sediments suggests that there may have been as many as 20 cold periods or glacials during the Pleistocene period. And during these glacial periods, ice advanced south into the northern hemisphere to cover large parts of Europe and North America. So, looking at this map, as you can see here, the large parts of northern Europe that were covered in ice. You've got North America covered in ice. You've got Greenland here covered in ice. You've got the Himalayas. These were all in the northern hemisphere. Now, in the southern hemisphere, you had Antarctica that was obviously all ice, but also the Andes Mountains in South America. Just 18,000 years ago, the ice had reached its maximum extent during the last glacial period. This map has shown us how far the ice spread over the British Isles, and as you can see, the white area here is obviously where the ice actually reached. In the key, we know that the green arrows have shown us the direction that that ice is actually moving, and we'll look at how ice moves later on through this topic. The beigey colour, this area here, is what we know as tundra. Tundra is where the ground is actually frozen, but it's not where the actual ice is. Now, this ice that spread across the British Isles was actually very, very thick, sometimes hundreds of metres thick in certain places. Even southern England would have been completely frozen, rather like parts of northern Canada are today. Now, between the glacial periods were warmer interglacials, as we saw on that last graph, which were at least as warm as today's climate, if not warmer. There's actually evidence, for example, that hippopotamuses lived as far north as Leeds. These fluctuations in temperature had nothing to do with human activities. There were no power stations or cars. These changes occurred over thousands of years, and you can see why we should treat yearly trends and one-off weather events with extreme skepticism when linking them to climate change. So how do we actually know what happened in the past? We can take core samples from existing ice sheets and look at the chemical composition of the ice and the marine organisms that were trapped in it at different depths. Scientists can then work out changes in temperature over the last few thousand years. Fossils are also good indicators of climate. Some fossilised plants and animals found in the UK could only have survived in a warmer climate. Others must have lived in a colder climate, so we know when those glacial and interglacial periods took place. Some of the landforms found in Britain today, so for example the valleys in Scotland and the Lake District, could only have been formed by ice, and we'll look at this in future lessons. So these can help to pinpoint where the ice sheets actually reached in the past. So, where is actually ice covering today? Currently there are two large areas of ice in the world called ice sheets, which you can see on this map above. The largest of them is actually Antarctica, and as you can see down here, this is the size of the Antarctic ice sheet, so it's huge. It covers an area of 14 million kilometres squared and actually holds 90% of all fresh water on the Earth's surface. In places, it's actually several kilometres thick. The Greenland ice sheet, as you can see here, obviously covering Greenland, is an area of 1.7 million kilometres squared, and over 80% of Greenland is covered by it. It is currently showing increasing evidence of melting due to global warming, so this ice sheet here in particular seems to be retreating. Now, smaller bodies of ice covering an area of less than 50,000 kilometres squared are called ice caps or ice fields, and it's important that we know the difference between these different words. They are usually found in mountainous areas where the temperatures are lower, such as Iceland. So Iceland is this little island here, and also the European Alps, so kind of down here, sort of in Europe where the Alps are. Now, spreading out from ice caps are individual fingers of ice called glaciers, or glaciers. They often form river valleys and extend down to an altitude where melting converts the ice to running water. Glaciers are found in every continent in the world and in some 47 individual countries. So it's really important that you understand that these three different terms are to do with scale. So an ice sheet is a large body of ice over 50,000 kilometres squared in extent. An ice cap is a smaller body of ice that's less than 50,000 kilometres squared that's usually found in mountainous regions. And a glacier is a finger of ice that usually extends downhill from an ice cap and occupies a valley. Most of this topic is going to be looking at glaciers and how they kind of erode and the impact that those have on the landscape. Now, glaciers begin high up in the mountains, as I say, off these ice caps, where snow collects in hollows on the mountainside and compacts to form ice, and we'll look at the formation of them in coming lessons. As the glacier begins to slide downhill, due to the weight of the compressed ice and gravity, it follows the easiest route and flows down river valleys. There are many glaciers in the Alps, like Kornegrat Glacier in Switzerland, but glaciers are found all over the world, as has already been mentioned, even on Mount Kilimanjaro in Tanzania, which is close to the equator.